This is Secondary 1 Honors, Quarter 3, Part 2, Video number 6. This is on the magnitude of a vector, and we'll also be talking about something called displacement. Okay, first of all, magnitude means the length of something, as we talked about in a previous video. And also, one thing that we're going to be using is we're going to be using the Pythagorean theorem to be able to find the magnitude of a vector. And just to review, the Pythagorean theorem is for a right triangle, meaning you've got a 90-degree angle right there. For a right triangle, the leg squared plus leg squared is equal to hypotenuse squared. And so you need to make sure that you understand that the legs are the two sides that make the 90-degree angle. The hypotenuse is the side that is opposite. So in other words, we would often see that called a squared plus b squared equals c squared, where c is the hypotenuse of a right triangle. Okay, so let's take the vector 3, 2. And so if you remember from our previous situations, we found that that is the magnitude, or a vector 3 on the right, to the right on the x-axis, and 2 up on the y-axis, or in the y direction. And so we can actually look at that if we're going to find the magnitude of the vector. Let me draw this. We can go to something like this where we have separated into two parts, and so where we have the vector 3, 0, and we can draw that like this blue vector here. So you start at just some point. Remember, with vectors, it doesn't matter where you start, just start somewhere. We go over 3 and up 0, and then if we add on to that the vector 0, 2, so starting at the same point, we would go over 0 and up 2. So one of the methods we can use is we can use this, and this, if we put the beginning points of each of our vectors together, this is what we call the tail-to-tail method. We're going to use a parallelogram. So if you complete a parallelogram, and then if you draw the diagonal from the beginning point to the opposite corner, that orange diagonal, that is our resultant vector, or the vector that is the result of adding the other two vectors. And so if we were to take away the pieces that we started out with and just looked at our resultant vector, what that means is that this resultant vector, if I start at this point, we're going to go over 1, 2, 3 and up 2. And so it's the same thing as what we would have if we didn't add the two vectors separately. So we would use this to add vectors together. And so, like I said, this method is called the tail-to-tail method. And it's okay, there's actually a method that I like better. And so there's another method, and it's called a head-to-tail method. And so as you can imagine, we've got the same two vectors. If we do head to tail, we're going to take our first vector, 3, 0, and we're going to add to that. But instead of putting the second vector starting there so that their tails match up, what we're going to do is at the head of this one, we're going to start there and put the tail of the other one. And so we're going to do that. So let me put that on here. So we're going to go 0, 2. And so remember, with a vector, because it doesn't matter where you start, you can really do head to tail or tail to tail, it doesn't matter. And then what you do is you don't have to make a parallelogram, which is why I like this method. You can just begin at your starting point where you began your sum, and from that point to where you end, that is your resultant vector. So this vector that I've got right there, that's what you get when you add these two vectors together. So here again, if we were to take off these pieces that we started with, we have this vector that is hold on, we're not drawing here, 1, 2, 3, and then up 2, and that's the same vector. So that's called the head-to-tail method. And so you just put them head to tail and then connect them, and that's your resultant vector. All right, we also are going to use that resultant vector to find what's called the magnitude of vector A. And so this symbol right there, that means the magnitude of the vector A. And so when you see that, that means find the length. How long is this vector right there? That's what we're asking you right now. So to find the magnitude, we would use the Pythagorean theorem. So of course this head to tail right there, that creates a 90-degree angle, and so we'll use that for our right triangle. And so if you look at this as, this is a leg, so I'm going to square it, so the length of that is 3, so I get the 3 squared, And this is another leg, so that length is 2, and so I'm going to square that. And then so I get 9 plus 4, 3 squared plus 2 squared is 9 plus 4, and I'll just call this hypotenuse little a there. And so that's going to be 13 is a squared. Now if you remember, when we solve equations we do the opposite. So the opposite of squaring something is to take the square root of something, and you did that. You've done that before. And so what that gives us is it helps us to solve for a, and so what we find out is that a is equal to the square root of 13. We can approximate that and get another number, but really quickly, when you take the square root of both sides, you hopefully remember that you do plus or minus, but because we're talking about the length of something, the negative doesn't make any sense, so you don't have to worry about that if you're finding the side of a triangle. So we would write here that the magnitude of vector A is equal to the square root of 13, which is approximately equal to 3.6. So if you do the square root of 13 on your calculator, you get about 3.6. And so that would be how long this is. Remember that the hypotenuse is the longest side of a right triangle, and so it makes sense that that's longer than the 3 and longer than the 2. Okay, let's try another one. We're going to find vector q, which is the result of adding the two vectors, negative 2, 1 and 5, 12. So on your grid, and this is at the bottom of your notes page, what we're going to do is we are going to, on number 1, where your point number 1 is on your grid, so it's got a 1 right there, you're going to draw first the vector negative 2, positive 1. So just starting at that point 1, negative 2, and positive 1. So negative means go left and then go up 1. And that's your vector negative 2, 1. And then let's use the head to tail method. So then we're going to add on to that. So starting at the head of that, so where the arrow is, we're going to add on the vector 5, 12. So starting right here, we're going to go over 1, 2, 3, 4, 5, and then we're going to go up 12, and then we end up right up there. And so to get our result, or our resultant vector, we're going to connect from our beginning point to our ending point. And so that's going to be our resultant vector. And so that means that basically we don't need these other pieces. They don't really matter. I don't want you to erase it off your paper, but this is the vector that is vector q. Because that's the sum of adding those other two vectors together. So if I'm asking for what is vector q, in other words, what are the components of vector q? So if you are just looking at the vector q, and if I said, well, what are the components of this vector, we're going to start right here and end right here. And how do we get there? Well, we're going to go over 1, 2, 3, and so, and then we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So when we write our components, we'll write it as a vector, and so vector q is 3, 13, and that tells us about the direction and where it goes, how far it goes. Now if I want to find the magnitude, so in other words, what is the length of this vector, so how many units long is it, then this is where we use the Pythagorean theorem. So here again, just look at your resultant vector, and if you look at your components, you've already written that out. So you've got this right triangle that is right there. So your leg right there and another leg right there, and you can use that for the Pythagorean theorem. So you're going to do 3 squared plus 13 squared, and that's going to be our, we'll call it little q squared, and that's going to be 9 plus 169, that's 3 squared plus 13 squared. Simplify that, it's 178, and then we want to know what q is, so I'm going to take the square root of both sides, so q is equal to the square root of 178. So then we would say that the magnitude of vector q is equal to the square root of 178, which if you put it in your calculator is approximately equal to 13.3. Notice the squiggly equal sign, that means approximately equal to, because we had to round it. Okay, on your page still, we're going to start with the point that says number 2 on your grid. And we're going to add these two vectors, 1, 3, and 4, 2. So if you want to pause this video and try it and see if you get it right, you're looking for the components of the resultant vector and the magnitude. So now is a good time to pause the video. Okay, starting at point 2 on your grid, just because that's a good place to start, you would draw the first vector 1, 3, so that means go over 1 and up 3. And then if you are using the head to tail method, which I recommend, then you would add to the head of that, so starting right up here, you would add the second vector 4, 2, so from that point go over 4 and up 2. And then to find your resultant vector, you're going to start at the beginning and go to the end, and that's where you draw your resultant vector, and that is what you get when you're all done. So that's your resultant vector. After you've drawn your resultant vector, you don't have to worry about the rest of the pieces of the triangle, because really the vector is all we care about there. So that's really all our concern right there. That is the vector, that is the sum. If I want to find the components of R, that's where I'm going to count. So keep in mind we're just looking at the orange one. And so we're going to count over to the right and then up to get from beginning to end. And so we count that, and it's over 5 and up 5. So our components of vector R are 5, 5. So 5, 5 is vector R. To find the magnitude of vector R, 5 squared plus 5 squared is equal to R squared. And you simplify that, 25 plus 25, and so that's 50 is R squared. And again, we have to find what R is, so take the square root of both sides, and you get R is equal to the square root of 50. So the magnitude of vector R is equal to the square root of 50, which is approximately 7.1. Okay, if you have any questions about finding magnitude, please make sure you come in and ask, because we don't want you to find all of the wrong answers, because that doesn't do anybody any good. Next, we're going to talk about displacement. And the displacement is the result of multiple actions. It takes into account many directions or distances, multiple things happening, not just two different vectors necessarily. It might be many more. So when we talk about displacement, we're going to start out with this little map, and it says that Jack went from a town located at point M. So that tells me he starts at point M, right here, and he goes through a windy road on the mountain, and he ends his trip at point N. So that's, obviously it's not, just a vector, it's, a series of winds and turns and twists. The displacement, though, is the shortest path from M to N. So the shortest way I could get there, like, if you were a bird and you could just fly straight, would just be to go straight from M to N. So make sure you're starting at M and you're ending at N, and that's going to be important because of your direction. If you started at N and ended in M, so if you were going that direction, that would obviously make you go negative, and that would be different. So make sure you know which way you're going. Okay, so the vector D is going to be 9, 4. So how did we get that? So if you can look at that and you know how we got that, then good job. If you're not sure, then we're going to start at M, and we have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots, and then we're going to go up 1, 2, 3, 4 spots, and that's where we get our components. To find the magnitude of our vector, I would ask that. So if I say, what is the displacement vector, or what is the displacement, then I'm asking for a vector. If I want to know how long it is from point M to point N, I will ask for the magnitude of the displacement. And so make sure you look for that magnitude word if you're going to be giving the length of it. So to find the magnitude of our displacement, which that's the symbol right there, you're going to do 9 squared plus 4 squared. So again, the sides of your triangle, that's 9, that's 4, and so 9 squared plus 4 squared, that's 81 plus 16 is equal to D squared. That's 97 is equal to D squared, and then to find D, you're going to have to take the square root of both sides. Remember, plus and minus don't matter here because we're talking about a distance. And so D is equal to square root of 97, which is approximately 9.8. So that would be our magnitude of our displacement. Okay, the last question on here, talking about Wendy walking, and she walks 8 blocks north, 2 blocks west, and 2 blocks north again. So what does that look like? So the first thing we're going to do is we're going to draw a sketch of the situation. So we've got 8 blocks north, and that would be up, and then we're going to go 2 blocks west, which is left, and then 2 blocks north again, which is up. And so that's the path that Wendy takes. So multiple actions here, multiple directions. If I wanted to find the displacement vector, then I'm going to begin at my beginning point and end at my ending point and just draw a vector. So that would be my displacement, that orange vector there. And so again, none of the rest of that matters. So if I was looking at my displacement, I could, go right here and do the same exact length and direction, and that would still be vector D. Okay, it doesn't say, she started at a particular point, so it's just that point, and that's fine. So if I ask what is the displacement vector D, then you would just give me the components. So beginning to end, we have a distance of 2 and a distance of 10. Now, of course, you could have gone this way and this way. That would be fine, which, by the way, that's one reason why that parallelogram method works with adding, but that's one way you could do that. So it's going to be -2, +10. -2, that's important that you have the negative there because that means that you went west instead of east. If you went east, it would be +2. So make sure you're paying attention to if you're going left or right, up or down. Okay, the magnitude of the displacement. So if she could have walked a straight path instead of turning at different places, how far would that be? So you're going to do -2 quantity squared. So remember what we've talked about, that is -2 times -2. Make sure you get the sign right. And then plus 10 squared, so it's going to be 4 plus 100. That's 104 is equal to d squared. D is equal to the square root of 104, which is approximately 10.2. So in this case, because she was walking blocks, it would be approximately 10.2 blocks. Now her actual distance that she walked was 8 plus 2 plus 2. So that'd be 12 blocks. She actually walked 12, but if she could have gone a straight line, she would have only had to walk about 10.2 blocks. Okay, that is the end of this video. You are now prepared to do questions number 25 through 47 on your worksheet. If you have any questions, please make sure you ask.